Welcome to the video on finding asymptotes in wholes of the graph of a rational function. Now with the asymptotes, we want to remember that we're looking at both the vertical asymptotes, if it has any, as well as horizontal or slant asymptotes, and then whether the graph also has a hole in the graph. Now when we're looking at this, the very first thing we want to do to get started is to find the domain of the function. And with this, looking at an earlier video, remember that the domain of a rational function is the values that do not make the denominator 0. So I start with this by thinking about what values of x make the denominator 0. X squared minus 1 equals 0 would factor as x plus 1, x minus 1. And that would mean that x equal negative 1 or positive 1 makes the denominator 0. So our domain is negative infinity to negative 1, pick up on the other side of negative 1 to 1, and then union, pick up on the other side of 1 and off to infinity. And again, for a further description of that, you can look at the video about the domains of a rational function. Now once we have the domain, the next thing we want to do is we want to see if the function f of x can simplify. So to do that, we want to factor the numerator and denominator of the original function. Well, we already spoke about the factorization of the denominator. It's x plus 1, x minus 1. And then the factorization of the numerator, well, that's a little bit more tricky because of it being a cubic. When we're looking at the possibility of factoring this polynomial, remember we did that in an earlier unit. And in the tutorial that talked about finding the linear factors of a polynomial, remember one of the clues is that if the coefficients of the polynomial add up to 0, 1 is a 0 of the polynomial, so x minus 1 is a factor. Now when I look at the coefficients of the numerator, I have a coefficient of 1, then a coefficient of negative 2, a coefficient of negative 11, and a coefficient of 12. And when you take 1, subtract 2, minus 11, and add 12, you indeed get 0 as a total of those coefficients. So I do know that x minus 1 is a factor of the numerator. And I can get the other factor by doing synthetic division. So we'll put our 1, and then we will write out our synthetic division table. Our coefficients of our polynomial in the numerator are 1, negative 2, negative 11, and 12. Bring down the 1, then 1 times 1 is 1, put it underneath the next number. Negative 2 plus 1 is negative 1. Then multiply, 1 times negative 1 is negative 1, add negative 11 plus negative 1 is negative 12, and then multiply 1 times negative 12 is negative 12, and add 12 plus negative 12 is 0. And then that tells us that yes, indeed, what we thought was true. 1 is a 0 of the polynomial, so x minus 1 is a factor, and the numbers in the bottom row are the coefficients of the remaining factor. The numerator polynomial started as a cubic. We divided about an x to the first, so these are the coefficients of a quadratic. So it's 1x squared, and then minus 1's the next number in that bottom row, so minus 1x, and then minus 12. Now once we get to this stage, we can see if the x squared minus x minus 12 factors any further. And indeed it does. We have our x minus 1 factor that we already took out. And then x squared minus x minus 12, well, that factors as x minus 4 times x plus 3. And that's all over x plus 1, x minus 1. Now when we look between the numerator and the denominator, we do see that we have a common factor pair of x minus 1's. So we can remove those common factors as long as we write off to the side the remembrance that that x equal 1 is not in the domain of our function. So we have to write x is not equal to 1 after a comma. Now we're going to set up a new function g of x, which is the simplified form of the original function f of x, And we can work with this the rest of the way through the process because f of x and g of x agree at all x values except at x equal 1. Now what about what information we get from this? Well, one of the pieces of information we get from this is we have a hole in the graph at x equal 1 because x equal 1 made the original denominator and numerator 0, and I had that common factor pair that came out, but it does not make the simplified denominator 0. So that means I'll have a hole in the graph at an x coordinate of 1 and the y coordinate where I'm going to ultimately, when we get to graphing, graph an open circle on the graph at that place is what you would get out from g of x when x is 1. So that we can designate as g of 1. And running 1 through the function g, we get that it would be negative 1 minus 4 multiplied to the quantity 1 plus 3 and then divided by the quantity 1 plus 1. Well, the quantity 1 minus 4 is a negative 3. So negative 3 times 1 plus 3 is 4. That gives me a negative 12. And then in the denominator 1 plus 1 is 2. Negative 12 divided by 2 is a negative 6. So we have a hole in the graph at 1 comma negative 6. Now how about vertical asymptotes? And we do see here that we do have a vertical asymptote. It's a value of x that makes the denominator 0 but not the numerator. And that value is x equal negative 1. So I have a vertical asymptote at x equal negative 1. And then lastly, what about the slant or horizontal asymptote? Well, we want to make sure that we do that horizontal, slant, or oblique asymptote portion from our simplified g of x function. And it's easier to get that if we have that multiplied out instead of in its factored form. So our g of x with the numerator multiplied out is x squared minus x minus 12 over x plus 1. And what we want to do is carry out the division of that rational function to get our slant asymptote. And we know it's a slant asymptote because the degree of the numerator is 1 greater than the degree of the denominator. So dividing, I have a denominator that's x plus 1, so it's of the form that I can use synthetic division. So I'll have my negative 1, and we'll have the coefficients of the x squared minus x minus 12. That's a 1 and a negative 1 and a negative 12. Bring the 1 down. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Then negative 1 times negative 2 is a positive 2. And negative 12 plus positive 2 is a negative 10. Now I didn't expect a 0 here because here we are looking at finding our slant asymptote. But our polynomial was degree 2 for our numerator. Our polynomial in our denominator was degree 1. So when we do that division, our quotient is going to have its highest power being first power. So using these coefficients from the bottom row of the synthetic division table, that's an x minus 2 for quotient, and our slant asymptote is y equal to that quotient. So our slant asymptote is y equal to x minus 2. And that gives you the asymptotes and the hole in the graph of the function f of x equals x cubed minus 2x squared minus 11x plus 12 all over x squared minus 1.